Okay, hi guys, welcome to the last part of our Euclidean geometry course. So this is the last part on tangents, which actually talks about tangents from a common point. Right. The theorem itself states that tangents from a common point are equal to each other, right? As you can see that we have tangent PA and we have tangent PB. So this is supposed to be equals to that. Okay, and this one also has a proof, so let's quickly dive into that, and we're going to use congruency for this one. Say we have a circle, given a circle that has a center. Let's extend this to meet that. Let me just try to twist this. Yes, we have something like this. Right. Let's try to shorten that. So this is that. Yeah. And the center at O. So what are we required to prove? Let's call this one A, B, and that's C. B being the point of tangency and C being the point of tangency for AC. Right, so you are required to prove what? You are required to prove that AB will be equals to AC. Right, what are you given? You can write it down. Given a circle with center O. Right, and also we are given two tangents. We are given tangents what? Tangents AB and also PC. Right, and then the proof itself. We just said the proof we are going to, oh, I'm skipping a step. Every proof should come with the construction. Can you guess what we construct? We are going to construct two radii, that first, and then we construct that. Let me not use solid lines. We construct this, we construct that, and then lastly we join OA. So we constructed what? OB, OC, and OA. From there we go for the proof. Right. So in the proof itself, one thing that you must know, right, first of all, we have that the angle OBA is equals to 90 degrees, right, and is also equals to the angle OCA. Right, why is that? The reason for this has to be a radius perpendicular or tangent perpendicular to radius. So it's tan perpendicular to radius or radius perpendicular to tangent. Right, the order doesn't really matter. So now we go for the proof itself. Now that we know this is a 90 and that's a 90. Right, so we have congruence in triangle ABO for the first one and the other triangle, which is triangle ACO. Right, what do we have? We have the line OB, which is equals to the line OC, and this is a radii. Secondly, we just had the two angles, which is OBA. Angle OBA is equals to angle what? Angle OCA. Why is that? They are both equals to 90 degrees, right? We just proved it. And then lastly, we have the line what? We have the line OA being equals to OA, which is a common side. Right, and then we can conclude that the two triangles, which is ABO, will be congruent to the triangle ACO. Right, and then the reason for this is right angle hypotenuse side, because we have the hypotenuse side, which is the common side, and we also have a 90 degrees. Therefore, from congruence now that we've proved that the two triangles are congruent to each other, then it means that the side AB will be equals to AC. Right, this comes from what? From congruency. Okay, so that's the proof. And then moving on, let's apply what we just learned. Remember this problem? We dealt with these two problems in the previous part. So let's just crop this one out. Let's just remove those two. This should go, that should go as well. Now what do we have? We should find TUVWX. Yeah, TUVWX. Let's start with angle T. How do we find T? How will we find T? In alphabetical order. TUVWXYZ. Let's start with T. First of all, we have that this is a tangent. So OA, the line OA, this one, will be perpendicular to that. OA is perpendicular to EB. Why is that? It's because a tangent is perpendicular to a radius. Then once we have that, then by default we have the angle OAB, which is equals to what? Angle OAB will be equals to 90 degrees because OA is perpendicular to EB. Right, and then once we have that, you can see that in fact T will be none other than what? Angle T will be equals to 90 degrees minus 31 degrees, right? Which should give us what? 90 minus 31 is none other than 59, which is 59 degrees. So we have a 59 degrees right here. What should we find next? We should find angle U. Angle U, we have this triangle right here. Tan-Cot theorem applies. So angle U is equals to angle T. Angle U is equals to angle T, and they are both equals to 59 degrees. Why is that? This is Tan-Cot theorem, right? Okay, and then we have another 59 degrees there. Then we should find W. How do we find W? W, it's what? TUV. No, we should find V first before W. How do we find angle W? Angle W is equals to that angle Y there on Tan-Cot theorem. Sorry, angle W is equals to, angle V is equals to angle W, Tan-Cot theorem. But we don't have angle W as yet, so we can't find V. But if you look at this straight line, you will see that you only have one unknown. So angle V is none other than 180 degrees minus 27 degrees plus 31 plus 59 degrees. Why? These are angles in a straight line, right? So that should give us 180 minus 27 minus 31 minus 59, which is 63 degrees. Angle V is equals to 63 degrees. Now that we have this to be 63, then we have W. Angle W, which is equals to angle V, like we said. And they are both equals to 63 degrees. Why? This is Tan-Cot theorem. Right, Tan-Cot theorem. And then from here, once we have that 63 degrees, and there was another way to find W. We could have used sum of angles in triangle FAC. But anyway, we move. Let's find X. How do you find X? Tan-Cot theorem again. If you look at X, there's X. Look at this triangle right here. You will see that X is equals to this whole angle right there. So angle X is equals to what? That gives us 58 degrees. Right, and that's Tan-Cot theorem. Right, and lastly we find Y. There's two ways to find Y. You can either use that 58 degrees there on X and the one on W, or you could have just used the fact that CB is equals to AB. And then what's that? These are tangents from a common point. Tan from common point B. So it's common point B, which means they are equal to each other. This is equals to that. We have an isosceles triangle. In fact, angle Y is equals to angle T, and they are both equals to 59 degrees. Why? These are angles opposite equal sides. Oh, and that's not even the only way. Even Tan-Cot theorem applies, whereby this angle right here will be equals to that angle there. So it all corresponds. And lastly, to find angle Z, sum of angles in triangle ACB, then you are done. Right, it's an easy one. Even for this, given that AP and a PT are both tangents, O is the center of the circle, so you should find A, B, and C. First of all, we need to find angle A. Let's look at that. To find angle A, we are going to first use this triangle right here. Look at it. This one, the angle APT, it goes this way. Right, so on APT, the first thing that we have that the AP will be equals to PT. And this is tangent from a common point, from common point P. Right, this is equals to that. which means then angle T3 is also equals to A, and these are angles opposite equal sides. Then we can use sum of angles in a triangle to find A. In fact, when we add this A right here and that A there and the 50 degrees there, it should give us 180 degrees, and these are what angles in a triangle. So we have 2A, which is equals to 180 minus 50, which means A is equals to 180 minus 50 is 130 divided by 2. 130 divided by 2, isn't that is 65, which is equals to 65 degrees. Right, now that we have A, then we can find B. Yeah, this is what I told you. You need to be careful. You cannot say this is tan chord, because this is not at the circumference. That's one thing you need to be careful of always. Okay, so we need to find C first before we find B, because we can see that this A right here is equals to that. Tan chord theorem, how many times? 3 times. So we have that triangle there. Then we have this tangent. So that is equals to that. In fact, angle C is equals to angle A, and they are both equals to 65 degrees on tan chord theorem. Alright. So that's tan chord theorem. Then we have angle B. Angle B is twice what? Angle B has to be 2 times angle C. Right, which is equals to 130 degrees. Why? And that's the angle at center now, which is twice angle at the circumference. Makes sense? I hope it does. There you have it. Then one last example, find x, y, and z. You can find x first, because you can see you are given that DE is equals to EB. By default, x is equals to 30 degrees. Angles opposite equal sides. Oh, this is given. Angles opposite equal sides. Right. Then secondly, you can do what? You can look for angle y. Angle y, you'll find it, sum of angles in a triangle. You have 30 degrees. Those two give us 60, which means this will be 120 degrees. And then lastly, now you need to find angle z. How exactly are you going to find z? Now this is a bit of a tricky one, but we need to figure it out. How to find z? Think about it. Okay, that's outside the circle. We have that this should be equals to that. Those are tangents from a common point, which means the whole of this angle right here, and you can see it's 60 degrees, has to be equals to that. So this is another, that's another 30. So it's a 30-30, same as this one, because they were given 30. So you have 60-60 now, which means even this one has to be 60 degrees. And in fact, all these sides are equal to each other there. It's an equilateral triangle. You look into that. And that marks the end of our Euclidean geometry course. The next session will be based on problem solving, how to apply this to prove that something is a cyclic quad, how to prove that lines are parallel, how to prove that this is a tangent, and all that. Thank you.